Welcome back, everyone. You're watching ISTA Conference 2021. My name is Konstantin Dinev, and I'm allowing my colleagues a well-deserved rest from moderator duty. The sessions so far have been exceptional on both streams, but ISTA 2021 is not over yet. We're back for one last session, which is being broadcasted on both streams. The last session we have for you is our closing keynote, and the speaker delivering it needs no introduction. I'm certain that all of you are familiar with agile software development and use solid principles in your day-to-day work. Our speaker not only came up with these, but also made them a de facto standard when talking about software development processes and practices. Don't forget to post your questions to the speaker in the YouTube stream chat. And without further delay, I'm really excited to introduce to you Robert C. Martin, aka Uncle Bob. Welcome, Uncle Bob. Glad to have you with us.
It's good to be here. Thank you very much for inviting me. Should be a fun session. All right, everybody. This is a talk that I have given many times in many places over the last several years. It's called Expecting Professionalism. And it begins with a venture into a fantasy land where I have become your new chief technical officer. This is probably not something you actually want because personally, I would not make a very good administrator. I'm a programmer, I like to code. But if I were your new CTO, then I would have certain expectations, certain things that I would expect that all of you would adhere to. And primarily, those things have to do with professionalism. I should say a word on this. First of all, are we professionals? Do we have a profession? What is a profession? What does it mean to have a profession? To have a profession means that there is something that you profess. There are rules, there are standards, there are ethics, there are disciplines that you profess. Do we have anything like that? Do we have standards that we all adhere to? Do we have a code of ethics that we all follow? Are there disciplines that we all use on a regular basis? Those are the trappings of a profession. Those are what help us to become professionals. Over the next hour, I'm going to be talking about some of those standards, ethics, and disciplines, and I'm going to phrase them in the language of expectations. What do I expect? What do customers expect? And what should you expect of yourself? Now, as I talk about these expectations, you will likely hear them with two ears. One of the ears will be the ear of the programmer. The other ear will be the ear of the customer and the user. The customer and the user's ear will hear something that makes perfect sense. These expectations are kind of obvious from the customer and the user's point of view. The programmer, on the other hand, will hear something that makes no sense at all. It will sound insane. That is how far our industry has departed from what customers and users expect. And so to begin, I expect a number of things. And here's the first thing I expect. I expect that we will not ship shit. Now, some of you out there probably have engaged in shipping shit. I certainly have in my past careers. I have been known from time to time to ship things that were rather smelly. This, unfortunately, has become relatively common. It is one of those bizarre situations where programmers now think that they must ship things with bugs. Now, consider, for example, how common it has become to ship the beta. A beta is something that you're supposed to give to a very small select group of trusted users. But we abandoned that, a decade or more ago. Now we just ship the beta. Hey guys, it's a beta. Try it. Everybody try it. If it crashes, well, remember, it's just a beta. We live in beta world now. Everything we ship is a beta. Oh, don't worry if it crashes, it's a beta. I use a piece of software when I'm flying my airplane, right? I've got a nice piece of software. It's written by some really spectacularly good software developers. This software is called ForeFlight, and I use it in the cockpit, and it's a lifesaver, quite literally, a lifesaver. It is very valuable software. Can you imagine if they said to me, oh yeah, we're shipping you the beta? Those guys. So far, I have not seen any indication that they ship shit. They ship good stuff. We should expect that of ourselves as well. Certainly our customers expect that. Our customers and our managers and our users, when they receive our software, they expect that software is good software, right? It's a perfectly reasonable expectation. They do not expect that it will have bugs. They do not expect that it will have defects. Why should we? Let me ask you this question. Are you using a bug tracking system? Something like Jira. Are you using Jira to track your bugs? Or there's a bunch of other ones out there. I'm not trying to pick on Jira. Just there's a zillion little bug trackers out there. Bugzilla's another one. Tons of them. Ask yourself this question. Why do you need an automated database-driven system to keep track of your defects? Do you really have that many? Do you really have so many defects that you need to put them into a database, a megabyte database, and collate them and sort them using a computer? Why is it that the defects you have could not fit on, an index card? Couldn't you fit them all on an index card? Wouldn't that be, something that would be, expected by your users and your customers? Wouldn't they think, they should have, a couple of defects as long as it's not too many. So that's the first expectation, right? We will not ship shit. Now, already I've lost half the group right there because, the attitude is, well, we have to ship shit. How else could we meet our deadlines? Well, there's a problem there, isn't there? We're going to discuss that problem. But before we do, there's another expectation. I expect that we will always be ready. Now, what I mean by this is that we're all following the agile processes here. Maybe you're using Scrum, or maybe you're using extreme programming, or maybe you're using FDD or whatever, some agile process that you are using. Agile processes break the project up into time boxes, little time boxes. In Scrum, they're called sprints. In extreme programming, they're called iterations. Everybody has a different name for them, but they're all the same idea, right? They're a time box, and the normal duration for the time box is 2 weeks. I don't know what you're using. I hope it's about 2 weeks. Personally, I prefer 1 week. I think 1 week is better than 2 weeks. A lot can go wrong in 2 weeks. I kind of like to shorten that so that not so much goes wrong. I know in the early days, and now I'm talking 20 years ago, Scrum thought that the size of the sprint ought to be about 30 days. Then later on, they kind of shortened it down to 2 weeks. 2 weeks is very common now. What should be ready at the end of the sprint? What is the state of the software at the end of each sprint? And the answer to that is that the software is deployable. From a technical point of view, it is deployable. It may not be deployable from a business point of view, but from a technical point of view, it is deployable. Now, what that means is that if the business came to you and said, we're going to ship that software tomorrow, you would say, okay, it works. It all QA is already signed off on it. All the features that we've implemented work just fine. All our tests pass. We've written all the documentation. So yeah, you want to ship it, go right ahead and ship it. That's the response from the development organization. The business may not want to deploy it because, well, it doesn't have enough features yet. For example, maybe log out is working, but log in is not working yet. The business probably doesn't want to deploy that just yet. But if they did, for some bizarre reason, we would say, fine, it works. Log out works great. If you've got some way that you can make money with a system that you can log out of, but you can't log into, go for it, because log out works. That's the level of always being ready that I'm talking about. We developers do not put up roadblocks and say, no, you can't ship it. You can't ship it because it's full of defects. We've got to burn it in for months. Has anybody done this burn in thing? You know, you have you take a month and you get the system set up, and then you just watch it for like weeks. And you wonder, I wonder if it's going to crash. And nobody's really using it. Maybe you've got some special users that are banging on it, or maybe you wrote some software that's pumping transactions into it or something, and you just kind of watch it and go, my God, is it going to work? Is it going to work? A burn-in sprint, yeah. A stabilization sprint, yeah. Well, and then if it goes long enough and it doesn't crash, well, then you think, well, I guess it must be okay. I don't want any of those. I don't want those. No, at the end of every sprint, you should know. You should know that it works, and you should be confident that you can deploy it if the business says they want to deploy it. Deployment should be a business decision, not a technical decision. From a technical point of view, we are always ready to deploy. I expect stable productivity. Stable productivity. Now, what an interesting term, right? Imagine that you're on a team, and this team is working on a greenfield project, right? It's a brand new project. There's no code. There's no code yet, right? It's brand new. You've got a list of requirements, and people are coming to you and saying, "Can you do this feature? Can you get this feature written?" And you think, "My God, there's no code here. Yes, I can get this feature done." And you start to code, and code pours out of every orifice of your body, and eventually you've got something working. Just in a matter of a week or two, you've got this feature working, and everybody stands around and they're going, "Oh my God, they got the feature done in just a week or two. Why, I wonder if they can do that again." And they hand you another feature and you go, "Yes, we can get that done." Now you come back to that team about a year later. Ask them to do a feature. Ooh, I don't know, man. That's going to be tricky. Yeah, I think it's probably going to take us 3 or 4 months. But you used to do these kinds of things in a week. Yeah, but you don't know how complicated this system has become, how tangled, how interwoven. If we touch even one line of code, all hell could break loose. No, it's going to take us many months. I'm sure that some of you have had that experience. This is not stable productivity. Stable productivity is when the productivity you have today is roughly the same as the productivity you had a year ago, right? The software does not degrade. The software you are working on does not get worse and worse and worse with time. Instead, the software you are working on allows you to remain productive at a constant rate. I expect stable productivity. How are you going to get that stable productivity? I mean, Customers expect that, right? They expect releases to come on a pretty regular basis, right? And they expect that the difference between the releases will be roughly the same. They got 7 new features in last time. They got 7 new features in this time. That's great. That's stable productivity. And that, by the way, that should not require that the staff increase by an order of magnitude every year, right? We should not have to add lots and lots and lots more programmers in order to get the same number of features in every year. That is what I expect. That's what managers would expect. That's what customers and users would expect. Stable productivity. I expect inexpensive adaptability. Inexpensive adaptability. Now, this is certainly what your users expect. You see, software is a compound word. It's made up of 2 words. The first word is soft, which means flexible. The second word is ware, which means product. Software, flexible product. We intend that software systems are flexible. The reason software exists in the first place is that we wanted to have flexible machines. We wanted to be able to easily change the behavior of our machines. And therefore, if you write software that becomes hard to change, you have thwarted the very reason that software exists. If your architecture is so convoluted that no one can add new features anymore, well, then your architecture is pretty bad, isn't it? And it has thwarted the reason that software exists. Customers expect to be able to change. Now, they understand that the cost of a change is proportional to the scope of the change. If it's a big change, it should cost a lot. If it's a small change, it shouldn't cost very much. What really drives customers crazy is when they ask for what they consider to be a small change, and you come back and say, that ruins everything. Our architecture is going to be torn to shreds. It's going to take us man years of effort to do this little tiny thing. Yes, the customers don't like that. Customers expect inexpensive adaptability. They should be able to adapt the software. They should be able to ask for changes and pay commensurate with the scope. They should be able to pay a cost that is proportional to the scope. I expect continuous improvement. Continuous improvement, which means that everything should continuously improve. Everything should get better with time. What should get better with time? Well, the code. The code should get better with time. The design should get better with time. The architecture should get better with time. The feature set should get better with time. Everything should get better with time. The code should not degrade. The code should get better and better and better with time. You see, we are human beings, and human beings make things better with time. Theoretically speaking, of course, human beings make things better with time. That's what it means to be human. Software is not an exception to that. Our code should be getting better and better with time, not worse and worse. It should not be degrading. The system should not get more and more tangled and messy with time. It should get cleaner and cleaner with time. We should be constantly improving it. I have a rule. And the rule is I call it the Boy Scout rule. And the Boy Scout rule is that when you check the code in, you always check it in cleaner than you checked it out. Every single time, every single programmer, check the code in cleaner than you checked it out. You know, it doesn't have to be a lot clean. It's just a little bit cleaner. As you're about to check the code in, do some random act of kindness to it just to make it a little bit better, and then check it in. Never check it in worse. Always check it in better, just a little bit better. Imagine if everybody just did that. The code base would get better and better and better with time. Productivity would increase. Adaptability would become less and less expensive. If you simply cleaned the code a little bit every time you checked it in. Never, ever check it in worse. I expect fearless competence. Fearless competence. What does that mean? How many of you have brought code up on your screen and the code was horrible? And the blood drained from your face as you stared at this code and thought, oh my God, this is terrible. And a little whisper in your ear said, well, you should clean it. And then the devil came and said, no, you must not clean it. Don't touch it, because if you touch it, you will break it. And if you break it, it becomes yours forever. And so you back away. You say, no, not me. I'm not going to be the one. I'm not going to be the one who tries to clean this code. No, because I don't want to own it. You've probably done this. I've done this. Everybody's done this. If you've been a programmer, you know exactly what I mean. This is a fear reaction. You have reacted in fear of the code that you created. The code that you and your companions created, you now fear it. You react to it with fear. I want you to think about that. I want you to think carefully about that, how wildly unprofessional that is, how deeply irresponsible it is to now fear the very thing you created, to have let it out of your control to the extent that you now fear it and have no control over it. You react to it. It does not react to you anymore. It now masters you. You used to be the master of all code, didn't you? You remember the day when you wrote your name in an infinite loop and you saw your name go up the screen and you thought, oh my God, the power. You felt like the master of the world. But now the code masters you. You are the slave. It is the master. This is not an acceptable outcome. Somehow, we're going to have to reclaim our competence, our fearless competence, because fearing the code is fearful incompetence. We want to become fearlessly competent. How could we do that? What could we do to make ourselves fearlessly competent? How can we conquer the fear? Imagine that you had a little button, just a little button. Maybe it's on your keyboard. And when you push that button, some lights would blink and some computer sounds would come out. And then a little green light would light up. And that little green light would tell you that the entire system works. Everything works. It's great. And you push that button and the green light lights up. Oh, it works. And the green light doesn't take very long to show up. Maybe 10 seconds, maybe 15, maybe 20 seconds. Ooh, push the button 20 seconds later. Green light. Everything works. Now, bring that code up on your screen. The horrible code. The code that makes the blood drain from your face. Bring that code up on your screen. You've got the button. The little thought in your ear says, well, you should clean it a little bit. And the devil can't speak because your next thought is, well, I could just change the name of that function. That function could have a better name. push the button. Still green. Okay, I didn't break anything. I think I'm going to split that function in half. It's a little long. Split it into two functions. Give them both nice names. Hit the button. Oh, still green. Good. This function could really be in that class over there. I think I'm going to move it over there. Hit the button. Ooh, red. Ooh, put it back, put it back, put it back. Push the button. Green. I see what I did. I did it wrong. It belongs in this class over here. Push the button. Green. If you had that button, you would not fear the code. If you had that button, you would clean the code. If you cleaned the code, then you would be fearlessly competent. You would engage in inexpensive adaptability. You would continuously improve the product. Your productivity would be stable if you had that button. How do you get that button? Well, there is a discipline out there. Maybe you've heard of it. It's called test-driven development. And in test-driven development, just a little discipline, just a little thing that you do every minute, every second while you're programming, and you're using test-driven development, you write a suite of tests in a very particular way, which I am not going to outline for you. You can look this up on your own if you'd like to. But you write yourself a suite of tests, and everybody else on the team continues to add to this suite of tests. And when you run that suite of tests, it tells you that there's nothing broken. And the discipline is such that the suite of tests you create is so complete that when that suite of tests passes, you know the system works. In fact, you know that you can deploy it. The suite of tests is the indication that you can deploy. Now, there are several things about this suite of tests that must be true. First, they must be very complete. That's one of the things that the discipline helps us with. It helps us to make the test suite complete. The next thing is that it must be fast. It must run quickly, a matter of a minute or 2 or 3 or 4, but not 20, not even 10. 10 minutes is too long. 5 minutes is stretching it. The test should run pretty fast. And you think to yourself, well, it's impossible. We've got a really complicated system here. There's no way to test it in 5 minutes. Oh, yeah, there is. Consider it to be a design challenge. Put your design hat out and think, well, we got to finish the test in 3 minutes. How are we going to do that? You'll figure out a way, believe me. And I can prove that to you pretty quickly. How many instructions does your computer execute per second? Most computers nowadays, have 4 cores and they're executing at 2.6 gigahertz or something like that. So that would be on the order of 10 billion instructions per second. Does your program even have 10 billion instructions in it? I mean, even if it's 1 million lines of code long, I don't think you've got 10 billion instructions, which of course means that if you're going to test all 10 billion of those instructions, you should be able to execute those tests in less than a second. Unless, of course, you are executing some parts of the code more than once. Are you testing some parts of the code more than once? For example, let's say you write a test to test a business feature, and then you write another test to test a different business feature, and then you write a third test to test yet another business feature, and all 3 of those tests have to log into the system and have to navigate through the navigation hierarchy to get to the place where they can test that business rule. How many times do you have to test login to know that it works? Once, twice, just a couple of tests you need to run. You do not have to log in every single time. How many times do you have to test a database query to know that that database query works? 1 or 2 times, depending on the circumstances. How many times are you executing those database queries in your tests? Typically speaking, you can use reasonable design principles to reduce the number of times you execute the same code over and over and over again. So once again, consider that a design challenge and solve the problem of how long the tests take to run. Never accept the idea that the tests must require hours. No, they don't. You can speed them up. I expect extreme quality. I don't expect bugs. I don't expect defects. You shouldn't either. You shouldn't expect defects. Nothing should be going wrong. When the users get the code should work. What a concept. What a concept. When the users get the code should work. Well, what do you think of that? Now, how do you do that? Oh, you know what you do? You test it. You test the code. You, the programmer, you test the code. You make sure it works. And you write it cleanly, and you write it in a way that you can understand, and you get other people's eyes on it so that they can look at it and they can see that it works. You make sure it works. Do you have QA? Of course you have QA. Get QA involved. QA should be helping you to make sure that this software works properly. Now, I got things to say about QA. I'm going to talk about QA in just a minute, but I want to drive this point home first. Bugs are not acceptable. Bugs are not expected. The bug list should be short. It should fit on a card, right? It should not be in some database that you have to sort and collate. Think about that, right? You go to your users and say, our bug list has 10,000 bugs on it. It's really difficult to find anything in there. We've got to sort it and collate it all the time. If you want to put some more bugs in there, go right ahead. We'll never look at them because there's no way we're going to look at all those bugs ever. Yeah, that's not a great message to send to the users and customers, is it? So, more on QA. I expect that we will not dump on QA. Whose idea was it to put QA at the end of the project anyway? Who thought of that? Who's the person who said, what we need is a QA group, and we're going to put that QA group right at the end of the project, and we're going to give them all the crap, and then they're going to test it. Who thought of that? Why do we have QA in the first place? What motivated businesses to create a separate group of people to make sure that the code did what it's supposed to do? Why did they do that? And the answer to that should be obvious to you. They created a QA group because programmers were not doing what they were supposed to do. Programmers were letting everybody down. Programmers were shipping bad code. And so the QA groups were created, and the job of the QA groups is to test everything that the programmers did. Well, that's just nonsense, right? We don't want human beings testing everything that the programmers do. Programmers are smarter than that. That's not what we want QA to do. We do not want to dump on QA. We want QA. We do not want to dump on QA. We do not want to say, I think it probably works well enough to give to QA. No, you say it works. And you know what QA is going to find? QA will find nothing. That is your goal. QA should find nothing. I expect that QA will find nothing. In fact, I want QA to wonder why they're there. I want the quality assurance people to say, I don't even know why we're here. And by the way, I want to move them. I want to take them out of where they are. I don't want them at the end of the project. I want to use them where their talents would really be useful. I want to take the QA people and move them to the beginning of the project. I want the QA people specifying the system. I don't want them verifying the system. I want them specifying the system in detail. And I want those specifications automated. The QA folks and the business analysts should be writing a suite of automated acceptance tests. These tests, written in some very high-level specification language, not code, something like an Excel spreadsheet, something like that, a nice specification language. The QA people, the business analysts should be writing those tests, and the programmers should be automating those tests so that when the business wants to know if the software works as specified, the business just hits a button and the tests run and the little green light says, yep, it works as specified. I want two streams of tests. I want the tests that the QA and the business people write. I want the tests that the programmers write. And I want them both running every time anybody does anything. I want you to hit that button, and a few minutes later, the little green light lights up. And the little green light means that the system does everything the programmers expect it to do, and the system does everything the users and customers expect it to do. You see the slide here? The slide here, I took this picture in 2008. And the hands that you see are the hands of the QA manager. The document that he is holding out for me is the table of contents for his manual test plan. It is not his manual test plan. It is just the table of contents. He has 80,000 manual tests that he must run, and he must run them every 6 months. He sends that list over to an army of people in India, and it costs him $1 million every 6 months. He's holding this document out to me because the year is 2008, as I said, and the financial crisis has begun. And his boss has just gotten back from the CFO's office, and the CFO said everybody's budget is getting cut by 50%. And this QA manager just heard that his budget is getting cut by 50%. So he's holding this document out to me, and he's asking me this lovely question. Which half of these tests should I not run? And I told him, well, you can cut the document horizontally or vertically or depth-wise. It doesn't matter. You're not going to know if half your system works. That is the ultimate result of manual testing. Manual testing is insane. Manual testing, using human beings to test an automated system is insane. It's immoral. It's absurd. And every time you do it, every time you run manual tests, every time you make a manual testing the chief way to find out if the system works, you are going to lose those tests. And you will lose them in one of two ways. You will lose them either because somebody decides it's too expensive and they cut your budget, as happened to this poor guy, or there's a much more insidious way that you will lose the tests. The programmers deliver to QA, but they do not deliver on time. QA had budgeted a certain amount of time to run their manual tests. That time is now shortened. Does the release date move? Of course not. Release dates don't move. Therefore, the QA people are squeezed. They're the ones that have to absorb all of the late time. And they realize that they don't have time to run all the tests. So what do? Well, they do an impact analysis. They think, okay, what changed in this system? Okay, we'll only run those tests. This is a bad idea, right? Because what you know perfectly well, when you make changes to the code, it can break things that are all over the place. And if the QA people decide, well, we're only going to test the things that probably changed, they're going to get that wrong, and they're not going to execute critical tests. You will lose the tests if you test manually. The only way to make sure that you properly test the system is to automate as many of those tests as you can. And, we're programmers. That's what we do. We automate things, for God's sake. People will look at it and say, well, it's really, really expensive to automate all those tests. No, it's not expensive. It's expensive to have human beings run them. It's not comparatively speaking, it's not expensive to have programmers automate them. I mean, that is what we do, right? We automate things. I expect that the system will not be fragile. I expect that the system will be robust. I do not expect it to break a lot. I don't expect any particular parts of the system to be more fragile than other parts of the system. I expect that we will cover for each other. I expect that if one programmer goes down for some reason, goes on vacation or gets sick or quits and leaves, whatever reason, that other programmers will immediately be able to cover for it. I expect that you work together so closely that if someone leaves, all the other people around already know what that person is doing and can step in for them. There are disciplines that help with this. One of them is called pair programming. You may use that if you wish, or use some other technique, but make sure that if you go down, someone else can cover for you. I expect honest estimates. The most honest estimate you can give, of course, is I don't know, but that's not a useful estimate. So you're going to have to make it more useful by defining what you don't know. And the way you do that is by giving, one technique is to give three numbers, right? You say, someone says, well, how long is it going to take you to do this? And you say, well, if everything goes right, it'll take me about 5 days. Probably, though, it's going to be more like 10 days. And if everything goes wrong, it's going to be more like 30. Now, that's a perfectly fair way to characterize the estimate. Managers don't like that, of course, because they've got this range now. But the range is actually good because the range is the definition of what you don't know. The range describes your uncertainty, and that uncertainty is fair. So don't give them a number. Give them a range, and then continuously adjust that range as you know more and more and more. And say no if the answer is no. Someone says to you, I need this by Friday. If there's no way you're going to get it done by Friday, then you say, no, can't get it done by Friday. Sorry, no way, can't do it. And they say, well, you don't understand. It's got to be done by Friday. And you say, well, you don't understand. It's not going to be Friday. Sorry, no. You see, you were hired for your ability to say no, because you are the one who knows. They're not. So you have to say no. You will save your company immense amounts of money if you say no at the right time. And be careful. There's a sneaky little way that people like you to get you to say yes. and it goes like this. Well, will you at least try? And your answer to that should be no, because you're already trying. How dare they suggest that you're not trying? Of course you're trying. Now, you probably don't want to yell. You probably don't want to stare at them and hurl insults at them. But imagine that, right? They're asking you at the end, well, will you at least try? Well, what do you think I've been doing? We've all been trying here. I mean, come on. The answer is no, because the answer is no. And with that, I think I will end this talk. Thank you for your attention. There's a few minutes left for questions and answers. So if you have questions, I'd be glad to hear them. And I might even be able to answer one or two.
Well, thank you very much, Uncle Bob. As always, your session is not only very informative, but it's a lot of fun. So we already have some questions that have come through chat. So the first one is from Radko. How do we execute longer tasks as sometimes a feature cannot be finished in 2 weeks, for example? How do you handle such cases to be release ready?
So this is a common question, and the answer always is you break that feature up into smaller features, which is always possible. It's always possible to do this because the job of a programmer is to break a feature down into individual lines of code. That's what we do. We break things down into smaller and smaller and smaller chunks until we're right down to an individual line of code. So what you have to do, if you've got a feature and you know this feature is going to take you more than 2 weeks, well, then you split it up into 2 or 3 or 5 features. And you promised, and you put those features into your iterations or your sprints. The business isn't going to like this. The business wants to think of the feature as a whole set. No, it's only one feature. Everything in this feature is just part of the main whole. But yeah, you can't do that. You can't let them do that. You're going to have to say, no, we really need to break this down into things that will fit in a 2-week time frame. And yes, what that means is that some of these features are going to be minimized until many other weeks have gone by. So, simple example, login. Everybody's got to have a login. Well, how do you define login? Well, I mean, the guy's going to enter their username and password. And if they enter their password wrong, we'll let them try 3 times. And if they fail on the 3rd try, we're going to disable their account for a day. And there will be a button at the bottom that says, remind me of my password, and we'll email something to them. And that will put them on a website where they can enter a special code that we send to them by text message. And that, okay, you get the idea, right? There's this really complicated feature that's called login. Well, I mean, the very first login you do, you could say to the business, the first login, it's just going to be username and password. That's it. None of these other things. Just use no 3 tries, no little button at the bottom, no disabling of the account. Just username and password. It either succeeds or fails. And then a week later, maybe, we could add the 3 retries, and then maybe in the following sprint, we could put the little button down there. And I don't know how long it's going to take us to disable the account. We really haven't thought about that. We're going to probably want to estimate that one a little bit later, but, we can probably break it up and smear it out over 4 or 5 or 6 sprints. That is how you take advantage of that. Never let them bundle everything together and say, this is the feature, it's got to be done, and I don't want to hear about any intermediate features. No, you have to do it with intermediate features.
That was very thorough. So I have one question that I wanted to ask you. You said at the beginning, so don't ship the beta, right? That's one of the rules. But usually through these rules, you have to fight sales and sometimes senior management, the business side of the company. So because of time to market, right? How do you deal with that?
Well, this is a really common question. Everybody wants to know, how do you face down managers who have their own set of constraints? Right? Now, the sales has a real problem, right? Marketing, they've got a real problem. They've got to solve that problem. And they're looking at the developers, they're looking at the technical team and hoping that the technical team has a solution to them. And maybe the technical team does, but maybe they don't. And you have to be able to tell them, no, sorry, we can't help you with this. There's just a certain set of physical laws here, and we cannot alter reality to meet your time frame or meet what you need. We're going to have to get creative and think of some different set of features or different set of behaviors that will at least satisfy part of your need, but we can't do this whole thing by the deadline that you're asking for. We can't. It's not going to happen. And if we try, we will fail. And if we fail, the whole enterprise fails. So let's not go down that path. I'm not trying to tell all the junior engineers in there that are listening to me here that you should roar around going, no, 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 no. That's not what I'm saying. But everybody should be looking for some way to achieve the goal. But for the senior people, the senior engineers, the senior developers, the people who have been at this for a decade, right? You are the ones who have the ability to go to management and say, look, this isn't possible. Sorry, it isn't possible. Now, let me give you a bit of advice here. We're programmers. We like dealing with machines. You and I did not get into this business because we like people. We like to fiddle with machines. We like to make machines work. So we are generally not good at confrontations. Usually, right? Usually a programmer is not someone who wants to get into a shouting match with his boss or her boss. Managers are different. Managers and salespeople, they like dealing with people. I know this is hard to imagine, right? But they like dealing with people. They like communicating with people, and they like the ability to manipulate and intimidate and use emotional force. An engineer finds the truth by observing and reasoning. That's what we do. Programmers do that. We observe and we reason. Managers and salespeople find the truth in a very different way. They find the truth emotionally. They get people to back down. So here's the scenario. Manager comes to you and says, I need it by Friday. And you say, I can't do it by Friday. And the manager says, you must do it by Friday. And you say, I can't do it by Friday. No, you must. You're not a team player. You're not helping me with this. And you, not wanting to go through this confrontation anymore, you start to say, well, maybe I could try. Now the manager has the truth, or at least in their perception, they have found the truth. Through a sequence of emotional manipulations, they got you to change your position, and now they know a truth. It may not be the truth, but from their point of view, they have learned that, oh yeah, if I push him hard enough, he's going to say yes. Be careful with this, right? You and I, programmers, we don't like this stuff, but we're going to have to get, I don't know that we'll ever get good at it, but we're going to have to get competent at it. We're going to have to be able to understand it for what it is, and then be able to stand our ground when it's really important to stand our ground. I had an experience many years ago. I was managing a group of programmers in England, and managing. I was like the lead developer, but I was responsible for projects, and I talked to customers and things like that. And I had one particular customer who had a desperate need, and I got my resources arranged, and I promised this customer, yep, we can definitely deliver, and we could. I knew we could. And then I sat in a meeting with a bunch of other managers about a week later. And bit by bit, I saw them starting to steal my resources. They would say, well, we could use that guy here for this because it's more important than that other thing here. And one by one, these managers using this emotional manipulation technique would sit there and raid my team and start taking people and taking hours and taking time. And I realized that this promise I made to my customer was not going to happen. And I actually threw a fit. It's not something that I usually do, right? I usually don't start screaming. I don't get red-faced. I don't get emotional. But in this meeting, I just kind of lost it. And I said, you cannot do this, blah, blah, blah. And it was remarkable what happened. All these managers sat back in their chair and they said to me, well, you make a good point. Now, I had not made a point. I used no reasoning at all. All I did was yell at them, and they all go, oh, well, you've made a good point. And I learned something that day. Sometimes just standing your ground is the point.
Okay. Thank you very much for this advice. I think we have time for one or two more questions. So have Kalina from chat asking, but customers don't expect us to say no. They always expect to hear, sure, no problem. How can we make them accept the reasonable no?
Well, you can't make anybody do anything, right? All you can do is make yourself do something. So if the answer is no, and you know that the answer is no, then you just have to stand your ground and say, no, it's not going to happen. Sorry. And does that mean you're going to lose your job? Are they going to fire you over this? They might. Okay. But they're going to fire you if you screw it up too. So you're kind of at a bad situation there. Maybe you think to yourself, well, at least I can keep my job for another month and then they'll fire me later because we didn't. But that's probably not a great way to handle it either. There is no way to make people do things. Now, what I would suggest, of course, is that you are ready with data. If you have data, if you know how fast your team can go, and by the way, how do you get that data? By measuring how much you get done in every sprint. That's part of the agile process, by the way. One of the reasons that we have sprints in agile is so that we can measure how much we get done in each sprint. And then we can use that as historical data to go to managers and say, look, the last 10 sprints delivered this much. You're asking us to deliver 3 times that much in a lot less time. So the data doesn't support your ability to ask for that. If you have data, at least you can use the data to make the case. That does not guarantee that they will accept that data. I've certainly experienced managers who looked at the data and said, well, that data is baloney. Okay, all right, well, the answer is still no. Sorry, still can't do it. Do not expect people to be comfortable. They're not going to be comfortable, because when you say no, that really hurts them. And they've got to figure out something else. It is your responsibility, however, as an engineer, to say no when the answer is no.
I think saying no is a pretty important message, throughout. I have one, it's actually a short question. The answer that you're going to give probably is not going to be so short, but what code coverage percentage is a good percentage? Range answers accepted too.
So I love this question. So yeah, what code coverage percentage is an appropriate percentage? Well, let me see there. If we were able to get like 80% code coverage, that would be pretty good, wouldn't it? That would only mean that 20% of the code doesn't work. There is no number other than 100%. There is no number other than 100%. The code coverage target is 100%. Of course it is. Now, can you get to 100%? Probably not. Think of it as an asymptotic goal. A goal that you are constantly pushing towards, never quite able to achieve. Sort of like, attaining your ideal weight. People aren't real good at that. Asymptotically approaching the goal. But never settle for a number. 80% is not good enough. 90% is not good enough. 95% is not good enough. Only 100% is good enough. And even if you can't get to 100%, the effort must continue to drive it as high as you possibly can. Every little bit, notch it a little bit more, try to push it towards 100%.
Right. Yeah. That's what I thought you were going to say anyways, but we have one other one. What about changing the perspective? Humans make mistakes. Some tend to be lazy. Some tend to be too much optimistic, etc. Maybe I'm going to add a little bit on top of that. Like, what is, for example, the difference on how you deal with junior and senior engineers? Because you mentioned that in the previous answer. Is it different that you deal with the younger teams and versus older teams, with the teams that have, more, I don't know, lazy engineers, too optimistic ones? Okay,
so replace the word engineer with doctor. Well, sometimes there's lazy doctors, sometimes there's incompetent doctors. Yeah, well, that's just the way things are. No. We need to be able to sort out very early on the lazy and incompetent people and make sure that they're not among our ranks, because we are the doctors. We are the ones who are responsible for the body of our companies. Software is the lifeblood of our companies. It is the lifeblood of our society right now, right? Society itself depends on software. Our civilization runs on software, and we are the doctors. So we had better be pretty competent. We had better not be lazy. We had better if there are lazy people in there, we probably need to give them other jobs, but not programming jobs, because there's way too much at stake. How should we relate between juniors and seniors? Well, one of the problems we have is that there are way too many juniors and not nearly enough seniors. And there are two reasons for that. One of them is that we try to take seniors and move them into management. That's probably not a good idea. We should probably keep these senior developers around for 15 or 20 or 25 years. The other reason is that the industry is growing so fast that the number of young people coming in completely outweighs the number of old people who are around. The number of programmers in the world doubles every 5 years or so. So that gives us this problem that we are in a perpetual state of inexperience. There are more young people coming in than there are old people to teach them. In a team of developers, you want to have some juniors, some middle, some senior, and you want to have a good ratio there, right? So you want to have some guys who have got 15 years experience, they've been around the block a bunch of times. They oversee some mid-level guys who have been around the block, 7 or 8 years, and then those people are the ones who oversee the juniors that are coming in right out of school. That kind of apprentice level kind of structure is what we all need. What we don't want is a team of 50 22-year-olds. That's not going to work. And we've seen how badly that does work in the past.
Yep, that makes complete sense. So we're out of time, and I really, really, really want to thank you for being with us this year.
My pleasure.
Your presence here was amazing. So I would wish you a good day. It's the beginning of the day for you, right?
Oh, yes, it is. It's about 11 o'clock in the morning.
Yeah, it's 7 p.m. already here. So, we're going to close this.
Good evening to you.
Oh, thank you. So thank you once again. And I really hope that we're going to see you again in one of the next iterations of ISTA.
Okay, next year, year after, something like that. Maybe it'll be live, huh?
That's what we're hoping. That's what we've been hoping for the last 2 years. And I'm so excited for all of the content that we were able to see today. As always, our goal is to deliver the highest quality sessions, and the speakers are what makes this event special, and they have once again delivered. We had to be online for the last 2 years, but we're hoping that 2022 is going to be a much better year for everyone, and that we'll be able to move back to the usual place where ISTA is held. We can't wait to see all of you watching online back on site, networking and watching the event in the venue. Once again, I want to thank all of our partners that supported us to make ISTA Conference 2021 a reality. I also have to give a big thanks to the 5 companies that are organizing this event. As with all good things, ISTA 2021 comes to an end. We enjoyed every single minute of the 11th edition of ISTA, and we're hoping, that not only us here in the studio, but all of you watching online have also felt the same way. We have plans to release content throughout the year in order to make your experience with ISTA more continuous. So stay tuned for that. Follow us on social media. That was it from us. Goodbye.